Hello again, Copper Canyon Algebra 2. It's Miss Castro. I hope that you're all doing well. And welcome to week 2 of the trigonometric unit online. So today you should be starting your 9.3 lesson, which is on the unit circle. And I'm going to be honest with you, this lesson is actually the nicest one. It doesn't require a lot of calculation. It just requires some understanding and knowing how to read the unit circle. So one of the main things here is understanding that what is the unit circle and how do I use it? And so today I'm just going to do a quick introduction of how the unit circle came about and what those values that you've seen on it represent. It'll definitely help you out when you get into your lessons. So quick recap. So you got to remember a little bit from geometry, which I know some of you definitely did not love. But anyway, so remember some of the special right triangles that you saw in or learned about when you were in your geometry class. So you had a 45, 45, 90 degree triangle. You also had a 30, 60, 90 degree triangle. Okay. Also at some point you probably learned this phrase right here, Sohcahtoa. Sohcahtoa. So remember, we're going to be using that a little bit today just because in some of your questions you're going to run into Sohcahtoa. Sohcahtoa was a nice way to help you remember those trig functions. There's 3 basic trig functions, and so it's kind of hard to remember if you don't have something to kind of help you memorize it, and so that was one way to help you. So remember, sine, S-O-H, Soh and Sohcahtoa stand for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and then tangent is opposite over adjacent. Okay, and all those come from a right triangle. If you had a right triangle, you could put different sides in terms of ratios. You know, opposite over hypotenuse would be the 2 lengths of these 2 sides, and that would give you your sine value, the answer to your sine. Adjacent over hypotenuse. If you put adjacent over hypotenuse, that would give you your cosine answer. And lastly, if you did opposite over adjacent, that would give you your tangent value. So let's go ahead and talk about unit circle and why it's called the unit circle. It's called the unit circle for a reason, because on that unit circle, it is based off a radius 1. So it's 1 unit in distance, okay? And so that really helps, and that's why they call it unit circle, because all the values we're talking about is based off of a right triangle that has a hypotenuse of 1, okay? So I went ahead and made some pictures here to kind of help visualize this. Picture's worth 1,000 words, at least that's what I tell everybody. Now the main thing here is you might be thinking, wait, why are we talking about circles if this is a trig unit? And here's the reason why. Yes, I had a circle, but within every circle you can create 3 right triangles. So here's the first right triangle. Now look at how I made this, right? So this is a 30, 60, 90 triangle right here. And so the main thing here is understanding, okay, look at where it's at. This is a 30-degree angle. Notice I also put the radian measure there. It's pi over 6, tomato, tomato, same thing. But remember, on this right triangle that I've created on this unit circle, you have those 3 sides. You have your adjacent side, which is right next to the theta. It's the one right next to it. You have your opposite side, which is actually opposite, or we say across from the theta, right? It's opposite. That's why they call this one the opposite side. And hypotenuse is always the longest side. As I said, remember, this is in terms of, hey, it's a radius of 1. And so that hypotenuse has a radius of 1. Now, when we start talking about values, you can solve all of these values based on some of your special right triangle rules and knowing that this is a radius of 1. So I'm going to go ahead and reveal these to you. What we really want to know is, all right, I already know this is a length of 1 for the hypotenuse, but what about the x distance and the y distance? How long is it from here to the end of this right triangle? It's obviously not 1. 1's all the way to the end, and it's just shy of hitting that. So if you use your special right triangle rules, you would be able to calculate that. And of course, this is in math, right? So we have specifics. That distance from here, the center of the circle, the origin, out to this distance on the x value, that is approximately, and it's exactly square root of 3 over 2. That is the distance from the center of the circle out to this length right here. So that is an important value that you would be using. That is your x value on this right triangle. Likewise, you also want to know what this distance is, the opposite distance, the vertical distance right here, right? From the x-axis straight up to the top of your unit circle. And so this is, if you were to solve it with using special right triangle rules, that would actually come out to 1/2. So you have all 3 lengths on this special right triangle. We already knew that the radius, the hypotenuse, was a distance of 1. That's a given. It's a unit circle. But calculating this, don't worry about how I got these values. I don't want to review geometry with you right now, but these are the distances that you'll be using to calculate a lot of your trig values. Okay, now the main thing here, this is your x distance, this is your y distance. So do you see this spot right here? This would actually be the coordinate square root of 3 over 2, comma 1/2. That would be the coordinates for this particular end of your right triangle. And this becomes important because on the unit circle, we're using that. When you get points on a unit circle, remember those are x and y values because this is your x distance, this is your y distance. So when you find these lengths of your right triangle, you're actually finding the x and the y, aka you're finding your sine and your cosine. So going back to it again, I basically just told you, hey, this is your x value, aka your cosine value, and this one right here, the 1/2, is your sine value. That's your y value. So you basically know what the coordinates are for this particular point right here. It is square root of 3 over 2, comma 1/2. And voila, you just found coordinates on the unit circle. So you'll be doing that a lot on all of these. I'm going to show you guys one more. I'm going to show you the 45-45 real quick. All right, so same unit circle, but now I've got the other special right triangle. So let me go ahead and plaster this sucker up here. All right, so once again, special right triangle. Now, obviously, you can tell this one's a little bigger. And let me just go ahead and put it there for a reference. So going back, this was the 30-60, so you can see that it was much longer on the x-axis than it was on the y. So this is a different triangle, but now we're talking about a different angle. So a different angle creates a different special right triangle. So this particular one is a 45-degree right triangle. So remember, doing some quick math, if this is 45 degrees and this is a 90, that means this is the 45-45 90 special right triangle, right? But again, every special right triangle has specific leg values. So I'm going to go ahead and reveal those to you. And again, this is going to help you guys determine what you're trying to find in terms of sine and cosine. So let's go ahead and reveal the x value first. All right, so the distance, if you were to solve this special right triangle, the distance from the center of the circle out to, now again, not all the way to the end, okay, because obviously this right triangle stops right here. The distance from the center of the circle to this point right here on the x-axis is basically exactly square root of 2 over 2. That's the exact length of this portion of your triangle, okay? Same thing, this part right here. Now let's think about it. If this is 45 and this is 45, that means they have the same exact angle lengths. So what do you remember about your legs on a special right triangle that have the same angle? If they have the same angle, then they must produce the same lengths. So guess what? Your vertical distance here is, ta-da, it is the exact same as the x value. If they have 45s, which they do, 45-45, that means they're creating the exact same lengths here. So the one to remember here is that the length here is square root of 2 over 2. That's your x distance, and it's also the same for the y distance since they're both 45-45, square root of 2 over 2. Main thing here is the spots that are, these locations that you're going to see on your unit circle, they came from special right triangles. The hard part is you're not used to seeing the answers like square root of 2 over 2 or square root of 3 over 2, so that might be throwing you off. Okay, don't let that worry. You're not going to memorize a unit circle. You're just going to use the values that are on them. Okay, so remember, two things to keep in mind. When you have those coordinates on your circle, whatever it is, those coordinates are actually telling you the cosine and the sine value. I always tell students to keep this in mind. When you guys are trying to help yourself remember it, I think of the alphabet, you know, A, B, C, D. Well, what comes first? C or S? Cosine is first, sine is second, and it just kind of helps me keep straight. Hey, which one's my x value? Is it sine or cosine? Think of the alphabet. Cosine, C comes first, sine comes next, helps you keep order. Cosine first, then sine. X first, then Y. Kind of silly, but definitely might help you out when you're trying to work through things quickly. Good luck, Copper Canyon. I'll give you some examples in my next YouTube videos.